Alright, question number 7. I wanted to do in practice and find one that gave us fractions so I could possibly show you how to do synthetic division with fractions. Also, I wanted to go over practicing synthetic division by finding them by hand instead of the calculator. Alright, so we first want to find the number of positive real and negative real zeros. So we got to count how many times the sign changes. Positive, positive, positive. So the sign has not changed. It went to negative, so that's 1, and then it stays negative. So there's 1 possible positive real zero. Alright. And then when we go to the negative side, we're going to be plugging in a negative x. Alright, so here's the long and short of it. When you plug a negative x into an even degree, like 3x to the 4th, it's not going to change signs. It's going to stay the same. So 3x to the 4th is going to remain positive because you're raising a negative to an even degree. It's going to stay the same. Every odd degree will change signs. So 13x cubed was positive. It is going to change negative, because you're going to have 3 negatives and it's going to be negative. Even degree x squared is going to stay positive. And then odd degree x to the 13, it was minus, it's going to change to positive. That one's going to change signs. And then the negative 4 is not affected by the negative x, so it stays. Alright, so with the negatives, we have positive, negative, that's 1. Back to positive, that's 2. Still at positive, that's 2. Back to negative, that's 3. So we have 3 sign changes, or possibly less than that by an even integer. So subtract 2, and that gives you 3 or 1 possible negative, 3 or 1 possible negative zeros. Alright, so we have 3 negative, or 1 negative, and then 1 positive. So now we want to try to limit these numbers, so we won't have to try everything that would be in our list. So let's make our list real quick, see what numbers we're dealing with. Alright, so my back number is 4. I don't really need the negative. My leading coefficient is 3. So factors of 4 are 1, 2, and 4. Factors of 3 are just 1 and 3. So your list would be positive or negative. All of these numbers divided by 1 would just give me 1, 2, and 4. And then all of these numbers divided by 3, I will have 1/3, 2/3, and 4/3. Alright, so we first want to find upper bound. Remember, upper bound we're going to do synthetic, and we want to find biggest positive integer, or the smallest positive integer that will allow us to try as few numbers as possible. And just because it's an upper bound doesn't mean it has to be a number in this list. Like, for example, I could try 3, and let's see if 3 is an upper bound. Okay. That means I only need to try 1 or 2, or some of these fractions. Alright, so leading coefficient is 3, and then 13, and then 1, and then negative 13, and then negative 4. We want all positive on this last row. 3 times 3 is 9. Add, we get 22. We get 66. Add, we get 67. So let's just roughly round. 3 times 60 is 180. Subtract 20, we're still at 160. And 3 times 160 give us 480. And we'll end up with something positive. Okay, so 3 is an upper bound. Okay, not necessarily the smallest one, but it's an upper bound. Alright, so let's see if we can find the smallest upper bound. Okay. So I'm going to drop all the way down to the number 1 because I notice there's a lot of positive terms. So let me see if 1 works. If 1 works, that kind of helps me out. I only have to deal with these fractions. 1 times 3 is 3. Add, we get 16. 1 times 16. Add, we get 17. 1 times 17. Subtract, we get 4. And 1 times 4 is 4. Add, we get 0. Alright. So 1 is the smallest whole number that we can use. And we have found out, since everything is positive, that it is an upper bound, and since we had a remainder of 0, we also found that it is the one and only positive 0. So I'm going to put a 1 here for my upper bound, and now I'm going to find my lower bound. I'm going to leave this because we're going to come back to that and use it later. Now I want to find my lower bound. So let's start out with -2, and we might drop down to -1. That way we only try 1 or 2 numbers, or we'll go bigger. -2, and then we're going to use our coefficients of 3, 13, 1, -13, and -4. For this stage, we want to see alternating positive, negative, positive, negative. So this is 3. -2 and 3 gives me a -6, and that gives me a +7. Okay, so right here we have a problem because that's positive. We need it to be negative. So I am going to need to use a number that when I multiply negative number times 3, it's going to be bigger than 13. So let's try 4. Okay, the only other whole number we have. -4 actually. -4 times 3. That actually only gives me a -12. So let's go to 5. -5. And again, or maybe for the first time, this number does not need to be in this list. It just needs to be a whole number to reduce the number of numbers that we have to try. Okay, so 5 is going to give me a -15. This gives me a -2. Negative and negative gives me a +10, 11. Negative and positive gives me a -55. Add, we get 68 negative. And then let's just round negative times a +60. It's going to be a +300, and that's going to end up positive. So we got positive, negative, positive, negative, positive. So -5 is going to be my greatest lower bound. Alright. And then the last stage, we are going to find the actual zeros. Okay. So we have found one of them. Okay, we found one of them. It was 1. We plugged in 1, we got a 0. So this is going to take my original function from a 4th degree, because we started out with x to the 4th power. Dividing out one of them gives us a 3rd degree. So this is 3x cubed plus 16x squared plus 17x plus 4. I'm writing this because I wanted to see if we could factor by grouping. It doesn't look like we will be able to. Even switching things around, we're not going to get the same thing. Okay, so let's continue trying with synthetic. Alright, so I'm just going to pick up from here with synthetic. I want to show you how to do it with fractions. To minimize the time you have to spend watching this, let me use a calculator to find part of the answer, and then we'll just do it by hand. So let's graph this. 3x to the 4th plus 13x to the 3rd plus x squared minus 13x minus 4. Alright, so let's graph it. Let's see approximately, looks like negative 4 might be 1, 2, 3, 4, 5. Okay, so negative 4, negative 1, and maybe negative 1/3. So let's try that. So we don't have to do a lot of guess and check. So let me show you how this works with fractions. So negative 1/3 bring down the 3. You're going to divide by the bottom number, multiply by the top number. Alright, so divide by 3, that gives us 1. Multiply, we get a negative 1. Combine, we get 15. Divide by 3, we get 5 times negative 1, negative 5. Combine these, we get 12. Divide by 3, 4 times negative 1, negative 4, and we get 0. Alright, so negative 1/3 works. Now, when you do it with a fraction, you have to divide this resulting polynomial by the denominator. So we would be looking at 1, 5, divided by 3 is 4. Alright, now we're going to try negative 4 and negative 1. Those are the other numbers we saw. Okay. Bring down the 1, and we get negative 4, 1, negative 4, and 0. Alright, and then we saw negative 1 was the last one. So notice how you're getting a remainder of 0 that lets you know that it's a 0. 1 times negative 1, and we get 0. So negative 1, negative 4, negative 1/3, and 1. Negative 4, negative 1, negative 1/3, and 1.